Section 1.6, number 44. We're given two functions, f of x and g of x. F of x is x cubed in this case. G of x is 1 over x. And we are asked to find the compositions f of g of x, g of f of x, and we're asked to find, if possible, f of g of 0. F of g of 0. Okay? So, for this particular problem, a f of g of x means that we take our g and stick it everywhere where there's an x in our original function, right? This is our magic box. So g of x is going to get cubed. Now our g of x was 1 over x. So this is 1 over x cubed. Okay. Now if we remember our rules about fractions and powers, this is 1 cubed over x cubed, but 1 cubed is 1. So in this case our f of g of x is simply 1 over x cubed. In B, we're asked to flip this around, g of f of x. Okay, so whatever we had for our f of x, we're going to stick everywhere where there's an x in our g function, right? So this is going to be 1 over our f of x. But our f of x was x cubed, so this is 1 over x cubed. So it turns out in this case that f of g of x is equal to g of f of x. This is not true in general. We're going to see an example coming up shortly where this is certainly not true. Okay. And we're asked to find, if possible, in our last step, f of g of 0. Okay. Okay. Well, we can do this a couple different ways. Well, we can figure out what g of 0 was, which is 1 over 0, and that doesn't exist, and we can't plug things in that don't exist. Or we can take our result and plug in our 0 for our x. Well, 0 cubed, 0 to any power is 0. This is 1 over 0, and 0 is unhappy on the bottom. So that means it actually doesn't exist. If we take a look at this function, let's see why it doesn't exist. All right, so our f of g of x came out to be 1 over x cubed. Okay, so when x is 1, x cubed is 1, 1 over 1 is 1, so we should be there. Minus 1, minus 1 cubed is a minus times a minus times a minus, which is negative. 1 times 1 times 1 is 1. 1 over negative 1 is negative 1, so we're down here. And as x gets arbitrarily large, 1 divided by something arbitrarily large goes to 0, so we get the 0 behavior here. As x goes to negative infinity, 1 over negative infinity goes to 0 on this side. Okay. But as x gets arbitrarily small, dividing by something small makes the fraction very large. Okay? And so we get these blow-ups, and at 0 we have this vertical asymptote. Okay? The vertical asymptotes cause problems. They're blow-ups. Okay? And dividing by 0 doesn't work in this case. So that is why we don't have this thing exist at 0. All right? And we're done.